Siemens, ingenuity for life.
Good afternoon, everyone. My name is Sam Schwartz, and I'm the Director of Marketing for the Energy Management Association, and I will also be your moderator today. Welcome back, and welcome for the first time. If this is your first time at an EMA webinar, we're happy to have you, and special thanks to Siemens for sponsoring this session. I'm going to go over a few housekeeping notes before we run into things. We will be holding a Q&A session at the end of the presentation, but if you have questions that come up during, we do encourage you to submit them at any time using the Q&A button. If you happen to be experiencing any technical issues during the webinar, please do use that chat function to inform the panelists and we will assist you. This presentation is being recorded and will be available for viewing within 1 week. And then finally, in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. So today's webinar is Agility in the Existing Building Commissioning today. And we have Dewayne Collins joining us here. He's worked in many areas of the facilities space over his nearly 20-year career, from controls technician to project management, regional to enterprise energy performance engineering for global clients, and creating innovative ways to meet client EBCx needs as commissioning becomes ever more digital. Dewayne has been involved in many diverse improvement projects, large and small. And as a business manager for Siemens Smart Building Commissioning, he currently works with field teams in Americas to drive innovation and results for commissioning clients. So without further ado, I'm going to hand it off to Dewayne Collins, and thank you again, everyone, for joining us. Dewayne?
Thanks, Sam. So to get started today, I wanted to start with our agenda today. What are we going to be talking about? First, I wanted to go through existing building commissioning, what it is, what it's not, why it's important out in this space. Then we're going to define agility in existing building commissioning, as well as give some examples about how you can bring some more flexibility, not only to your customers as providers, but as building owners, what levers you have to pull to help fit these projects better to your site. We'll also go through some project examples, and at the end, we'll have a Q&A session. So to start, existing building commissioning, or EBCx, what is it and what's the industry need? To start, I wanted to go over what it's not. More succinctly put, I wanted to go through some terms that you probably hear out there, more or less to give you an idea of what we're not talking about today. So the first one being new construction commissioning. You'll oftentimes hear this as CX or NCCX. This is really that initial commissioning on a facility, all the systems involved, right? This is done and commissioned to the spec as that building was built. And the focus is on a quality handover to that owner. Everything needs to work per the spec, right? The second one is retro commissioning. We often hear this all over the industry, often referred to as RCX. So the intent of retro commissioning is to bring a facility or a system back to its basis of design, right? It does not consider current facility needs. This is often the most misused term in all of commissioning. You'll hear everybody from utilities and sometimes RFPs that come out where they say it's an RCX or a retro commissioning. What they're really looking for is existing building commissioning. We'll get into why here in a moment. The last most common one that we see out there is either monitoring or ongoing based commissioning. MBCX or OCX is typically the acronym that you're looking for. This is commissioning based around software, right? So more often than not, it's a fault detection based commissioning. It's continuous, whereas the other two are more of a project style orientation of commissioning. This will have some software set up in the beginning, and after the fact, it's usually more of a service that's continuous over time, right? So these are the three main ones that we're not discussing today. What we are talking about is existing building commissioning. And the biggest difference between this and the other ones we just talked about is that existing building commissioning is focused on either system or facility, current facility requirements. How do we need that site to operate today? A perfect example, I worked in office space that were formerly semiconductor labs, right? So there's a huge change in use in those, and oftentimes they benefit by bringing that facility up to how they currently use it. I want you to turn your attention to the graphic on the bottom. These are common steps in existing building commissioning. The first step being your assessment. Oftentimes you'll hear it referred to as the planning phase. This is where we're trying to get our head wrapped around what's going on at site, what types of equipment do you have, what are your CFRs or your current facility requirements, how will the project planning go, what types of meetings do we have, who needs to be involved. Then is the investigation. This is really the boots on the ground portion of existing building commissioning, where we're getting our hands on those equipments. We're finding out what those repairs or optimizations might be, and we're building a list of solutions for that site. The implementation part is pretty straightforward. We meet with the client to discuss of these things that we found through our assessment and our investigation, what things would we like to implement? And not all things at all times get implemented in a traditional existing building commissioning project. You may uncover rather large capital items that would need to be added to repair or improve the facility. And so those may be put off to a separate phase. Typically, we lead off into a handoff phase where we kind of collate everything that we've done. This was fixed, this was optimized, these items were left to a different phase. And that's all done in the handoff reporting. We also wrap up any time that we may have spent with the utility to gain outside funding. And we may make a plan to implement the other items that we found that just weren't in the budget for this round. Persistence is fairly obvious. It's some sort of recurrent activity in which we ensure that all the things that we implemented persist over time. And that may involve seasonal checks. That may just involve a quarterly or monthly investigation, typically through data, to see how those things are operating after the fact. What we're going to be talking about today and what kind of agility is in this arena for us at Siemens, it's treating this more of a modular program where we can bring any or all of these phases to a client, but it's not just these individual components, it's also right sizing existing building commissioning to tackling any or all systems. And we're going to get into examples of that in the next section. All that to say is that typically you're looking for a building about 3 years old or older, and it's had some type of major change in space use. It may also be a change in current facility requirements, and we'll uncover some of those as well as we move forward. I wanted to talk about why or some of the outcomes that typically come from existing building commissioning. A lot of the information I'm going to be sharing in the next few slides comes from what's called the Value of Commissioning Market Survey from Building Commissioning Association, or EBCx. They share these every few years to give an idea of the different types of commissioning, what they produce, what they are, and really get a sense for what the market is looking at in terms of commissioning out there. But for existing building commissioning, in their last annual report, or I guess it was a report over time, took a look at this information and said that the majority of these end up saving 10 to 20% annual savings. That's energy savings. And we find that, and I can say this anecdotally, we find that does shake out. We find that it's somewhere in the middle of that, typically. They also share that the overwhelming amount of these projects have a 1 to 5 year simple payback. And granted, this is all with and all dependent on the items that you have in scope as well. We tend to find that most of ours are a 3 year and under payback, but it falls right in line with what you're seeing here. Next, let's talk about why facility managers are buying these types of projects and really what they're looking for. I want to look past the first one, which is energy savings, because I think you'd be hard pressed to find anyone out there that isn't happy to obtain energy savings. But I can say in my work in the field, the next 5 are ones that we see absolutely every time on these projects. So a lot of these folks are looking for system performance, right? We need it to do the thing we need it to do when we need it to do it. It needs to heat them up, cool them down, whatever we might need. Of course, thermal comfort. A lot of these folks are dealing with hot, cold calls or otherwise problems in the space, right? So that's the second biggest one. adequate IAQ. That doesn't necessarily mean things like CO2, in the space. It may have to do with some type of process that they have in the space where IAQ is critical to that. Another big one that's gotten bigger and bigger, especially as utility companies out there are starting to create more commissioning-centric programs, is looking for outside funding. Now, we're all used to rebates and incentives, but like I had mentioned, there's more programmatic ones that are coming out in basically every state at this point to approach more of a commissioning orientation on these projects. The last one that we're seeing more and more of has been training operators and occupants. I think we've all seen, whether you're a provider or a facilities owner, that you have more and more new staff coming into the workforce to operate these facilities. And they've got a big learning curve to learn how these things work, how they interplay with each other. And we're in a unique position when we provide an existing building commissioning, not only to get all that up and working as they need it, but we're essentially also building a operating guide for the facility as well, which can help get these folks up to speed much faster, as well as understand why things were an operator override, why we left this damper fixed, things like that. So I want to get into some of the why. These are the main things that people are talking about these days. And to do that, I want to look at a different data set that comes from the Commercial Building Energy Consumption Survey, or SIEMENS. And there's something fascinating that kind of came out when you look through this data, specifically for even newer buildings. So for buildings constructed from 2000 to 2003, so we're looking at buildings that are currently pushing that 20-year or better mark, the HVAC energy intensity in these buildings has been on the increase. In 2003, they found that HVAC was about 33.1 kBTUs per square foot, and now we're all the way up to 42.8. So a pretty dramatic increase for relatively new buildings. The opposite is true of older buildings when you dig through the data. But when we look at this group of buildings, let's take a look at why. We're getting to a point where a lot of pieces of equipment and facility have a lifespan of around 20 to 25 years. So aging equipment is certainly a part of this. What we've found is that in buildings of this age, there's increased complexity over its older partners out there. Fewer facility staff has been a big one in the last 20 years. It used to not be uncommon that you would have a full facilities team for one building in a municipal area, and now it's not uncommon for that team to cover 5 buildings, or for it to be farmed out to a provider right now. Smaller budgets as well. We've seen a lot of economic turmoil over the last 20 years, which certainly leads to deferred maintenance and less of the things that needed to be done over that time handled. So it's for that reason, existing building commissioning has to seek to maintain the performance of ever increasing complex buildings, while keeping in mind that some of those older buildings, while not as complex, can still be well served by existing building commissioning practices. Next, I wanted to give you an idea of what typically are the findings that we have in an existing building commissioning. And this gives a lot of reason to why SIEMENS might be presenting on something like this. The reason being is that most of these are control related issues. So it's common things, right? We'll go through them: scheduling, override correction, implementing resets, modifying set points or modifying the sequence of operations. Smaller things that are more maintenance related activities like calibration and loop tuning are often things that are suggested through these programs. And clearly, there's oftentimes mechanical repairs and general maintenance items as well. But at only 3% of that list, they are a very small portion of what is typically done in existing building commissioning. In addition, the labor distribution of how these are typically manned is another great reason why vendors like SIEMENS are in this business, because most of that labor is the controls contractor. Most of that labor is the mechanical contractor. And since we already provide commissioning, you kind of have a one throat to choke area to go to for existing building commissioning. So all that to say, this is existing building commissioning. This is how it performs. This is why it's important. I want to talk a little bit more about our orientation in it, and how we might change that. So I use the word agility, and you might be thinking, well, really what he's going to talk about is just scale. And that's really not what we're talking about today. I would define agility as the point where flexibility meets scale to maximize that outcome, either as a facility owner or as a provider. And the way that looks, when you take a look at traditional existing building commissioning, it is oftentimes done for a whole facility, all systems, right? It's not strategically focused. It's meant to serve the entire facility. As a result, clearly that can make it somewhat cost prohibitive, right? That's a rather large project. And as a result, it's also very disruptive in a lot of cases. We're talking about things like planking cubes to get to the tiles, turning off equipment, a lot of disruption in the day-to-day activities, specifically if you're doing a whole facility existing building commissioning. A lot of our industry is what I'll call pencil and clipboard still. While we are making good strides in kind of improving how that works, a lot of it's not data forward. And then there's a lot of inherent problems with that, specifically that there's large amounts of equipment that are typically checked on a percent basis. That is to say, I have 400 VAVs, but in order to keep our costs down through this project, we're going to investigate 10% of them at random, or maybe 20%. So we may not be hitting the boxes that have problems, which clearly would lead to some labor inefficiency if we're popping tiles and we're not getting the results from that random sample. And as a result, with kind of this broader non-data forward approach, we kind of tend to spend more time with the things that don't provide results. So if to use the Pareto principle, that is to say that we probably spend 80% of our time for something that only drives 20% of the desired results in a lot of cases. So that's traditional, right? Existing building commissioning from an industry perspective is expected to be a whole facility process, all systems process. When we take a more agile approach, and the way that I look at projects in working in around the world on stuff like this, I find that agility can be found in two main areas, and that's in financial as well as technical agility in these projects. We're going to go through examples on these, but to run these down from the financial side of things, can we focus on the client's revenue priority? Where do they make their money in their facility? And does it behoove us to focus on that revenue stream? Can it fit budget constraints? This by far is one of the biggest ones out there. And there's a few ways that we can go about that. We're going to talk about a financial orientation of that as well as a technical orientation of that as well. Another financial spot to be agile in would be procedurally, how do they buy? Or what pathway do I have to take to have one of these projects at my facility? On the technical side, a lot of this comes from either a digital approach or awareness of outside influences and regulation around us. We're also going to talk about what type of strategic benefit digital tools can provide, and getting an idea of where you might want to work in that facility. What type of labor benefit? Can we be a lot more lean with our labor? Because at the end of the day, when you get into that investigation phase where you start having engineers and technicians on site, that's where the bulk of your cost is. And if we can take a more strategic approach or data-driven approach, oftentimes we can lean that up quite a bit to where these projects look a lot more attractive from a technical perspective. And as I had mentioned, what types of outside influences or regulation may be influencing the customer site, and do we need to have an approach that takes that into account primarily? Okay. So we're going to go through the financial drivers or agile points that we can use for existing building commissioning. And the first one is client revenue priority. Again, like I mentioned, can we identify the areas at the client side or in that facility that help drive significant revenue or the bulk of the revenue? And typically, a lot of these are critical in nature, right? Not just because they have the revenue drive behind them, but they may also involve some type of safety concern, or there may be critical in terms of the conditions that they're trying to keep in those spaces. And hospitals are a perfect example of this. I took a look at a survey from 2019, a Merritt Hawkins survey that looked at the top 10 physician specialties driving revenue in the hospital space. And I highlighted a specific group of them. You'll notice that 55% of these top 10 revenue generating activities are surgery related. In addition to the revenue, they're also the most critical at these sites, right? So that is to say, if we had a customer that's having some difficulty knowing where to start with their existing building commissioning, helping them out on this side to improve revenue as well as performance and safety can be a huge benefit to these clients. So that is to say, not focusing on the whole hospital, but maybe getting that start in some of these facilities or some of these portions of the facilities that drive revenue and are critical in nature. Right? Existing building commissioning is a huge help in this space, specifically if we target what's important to that customer and to their clients as well. Second, in financial agility, I would say is the lack of budget on a lot of these. And we can take a look at this from a non-technical perspective. So there are always areas in a facility that produce the significant amount of work orders. And quite often they're pretty regular. There's also typically areas in a facility that produce the significant amount of hot cold calls or other space complaints. So as a result of that, purely from a budgetary constraint perspective, when we take a look at the work orders and hot cold calls, we may suggest that we can limit this effort to, say, 3 air handlers as opposed to all 10 that may be at this customer site. So that is to say, we take all of the steps that you see for existing building commissioning and just apply that to air handler 1, air handler 7, and air handler 4. Clearly, this helps drive down a lot of those work orders, so it frees up staff, right, on some of the things that are really eating up their time and their maintenance budget. So clearly, we get to a point where we're providing a better result by prioritizing those pieces of equipment. We get to a point where we're generating not just energy savings and improving performance, but operational savings, physical time on site. As I had mentioned before, one of the top drivers in this space right now is not only budgetary, but getting people up to speed. And those tasks can't be done if you're spending the majority of your time with these pieces of equipment, kind of eating up not only your budget, but your time. So a lot of benefits in taking a look at this from just a purely work order, maintenance budget and calls perspective. That's not technical either. The last financial one I wanted to talk about was procedural purchasing. And this affects mostly institutional clients, in some cases municipalities, local governments, that can't purchase capital improvements directly, right? They have to go out to an RFP process, for example. Oftentimes they kind of lack an intuitive or comprehensive way to come up with what that project might be. And in a lot of cases, if we apply just the initial 2 phases of existing building commissioning, we understand what the problem is, what they need to have happen. We have a list of those improvements that may need to take place that can be included in a comprehensive RFP without doing the full existing building commissioning right off the bat. This is a great method for improving the RFPs for these types of customers where they do have to go through this RFP process. And a perfect example would be K through 12 schools. They often require a study up front to understand where that budget might go, because they have to go back and ask for that budget and then put out an RFP as well. And they can often do a turnkey project, right? Ideally, we come at this and we're able to complete all these phases. So it's done and wrapped up, and we've gotten the majority of the concerns handled. We've identified some of the capital stuff that need to be handled separately. But if they can't buy like that, we need to improve the process for them to get to that result. So another way to be agile is to understand the procedural purchasing, understand where you may need to break up some of those phases of commissioning in order to get that client to the end result, right? And doing the engineering up front may be the best answer for them. So those are the three main financial levers for agility that I see. I wanted to talk through some of the technical as well. And I've got three examples of that. The first being digital forward. So in a lot of cases, they may understand that these pieces of equipment are troublesome to me, but is the juice worth the squeeze in a lot of these cases? So we have tools that we use to go out and analyze. An example here is air handlers on a site. And we can do several hundred at a time. There are more checks than what you see on the left-hand side. I believe we have 30 or 40 that we do just to start on a project to get an initial idea of what's going on in that space without a whole lot of effort up front. So you see pretty common things, right? Is the mixed air temp reading correctly? Outside air temp readings, which clearly can affect a whole site in some cases. Fan loop tuning, everything from valve stuck, things like that. We can go out and find very quickly, are these things that we can produce a worthwhile outcome with minimal cost upfront. So from a digital perspective, being able to vet out some of these things really quick provides a lot of results and is a little more technical than the budgetary example I gave earlier, where you look through the maintenance budget and see where are we spending that time. So it only requires a small amount of data. We're not talking about months and months of trend data to understand any of the things that you see on the left-hand side there as far as the checks. In addition, I think this shows something that if you've been in the field long enough, you should intuitively know, but there's a heat recovery unit 1. There's not a lot to those pieces of equipment, right? So this kind of vets out clearly why the heat and vent unit would probably be less complex than the other air handlers on this site. So as I had mentioned, this is intended to upfront know where we might best spend our effort for the highest ROI possible upfront, right? No boots on the ground. We can do this analysis quick. Data forward is where we're looking at for this technical example. So clearly having that information up front or being able to identify is the juice worth the squeeze kind of scenarios are pretty big on the front end. But there's also another way to look at this from a technical perspective where we might see other types of results. And in this one, we're looking at how does a digital orientation improve productivity? One of the biggest costs in almost every single existing building commissioning or any commissioning for that matter is the terminal units, right? You can have several hundred of these on a site at a time. And oftentimes, the way that these are scoped out is that we'll take a random, we'll physically inspect a random percentage of those boxes on site. And that can be anywhere from 10 to 20%. What that yields, though, is often those boxes are missed. The ones that have some impact on there, outside of anecdotal stuff, right? You're going to have people in the space that will say, this is a problem, or it's never cool enough in here. But we can be more efficient with that. What you're looking at on the left-hand side, or excuse me, the right-hand side, is some data that we pull for terminal units, quick moment in time data, no trends needed, that we can take a look and see what are the problem boxes are out there and what types of problems do they have. So when you have this orientation, you can actually plan to go after the boxes that actually have issues up front without a random sample that may not move the needle on the ones that you go to look at. Now, if any of you have spent time on site, boxes are some of the worst things to physically investigate. So there's a huge amount of productivity that's picked up here, right? You have to involve a ladder. You have to kind of guess where they might be. And then after that, can you even access it, right? Is there a fire line in the way or a ductwork in the way? There's a lot of issues with looking at these, and oftentimes these are a small piece of the pie. But if we know what those issues are, what boxes that we will move the needle the most. We can also take a look at what types of parts that we might need up front to get a budget for that. This is a far different orientation from a productivity standpoint than you would normally have through random sampling. Right? So this is a pretty big area of improvement through data upfront. The last agility lever that we have to pull, I think, in the technical side is outside influence. That can be anything from special events to regulation that comes into play for many of these sites. A big one that we see a lot in larger municipalities now is a requirement of EUI reductions or performance of a building at sites of a certain size. I think in my area, it's anything over 50,000 square feet downtown has to hit X target. There's also unexpected events that can upend operations and also future plans for the business. Weather is a big one. I know the Northeast right now is experiencing quite a bit of smoke. Here on the West Coast, we see that pretty often, and there's several locations up and down the coast from the fires that we experience in the summers that have changed requirements for outside air over the years because it has gotten that bad. So there's a lot of instances in which we commission those new regulations just for fresh air and summer fire smoke to improve that situation. Infrastructure is another big one for sites that require a lot of readiness, but may be located in, let's say, Texas, where the energy infrastructure is somewhat unreliable at low temperatures. We do commission jobs to look at the systems that they need to keep up and running. What is my critical path should that situation happen? I may be at peak already on my generator. How can I limit that? And the best way to know about that is to go through those systems, see how they operate, ensure that they perform well, and see what you need to do to get them to that spot. And also outbreaks. It can be anything, right? We've had examples of Legionnaire's disease out there in hospitals and other settings, but I think COVID is a perfect example of moving fast in an unexpected situation that we found ourselves in. What you'll see on the left is something that we put together when we went through the ASHRAE Epidemic Task Force recommendations. And we had to break things down into steps. Number one, they had to be remotely accessible. There was a lot of movement in those facilities in terms of who's going to be there, when and how, and what they need to be doing or looking at. So remote access was a big one. Number two is really where existing building commissioning fit in, right? Are the systems functioning correctly? Before you can do anything to meet these requirements, you need to know, does it work? Can it perform the new strategies? So what types of not only repairs or corrections do I need to make, but what types of improvements do I need to make to my facility to meet all of those requirements in step 3? So in this instance, the best model for getting up to speed for those ASHRAE recommendations for COVID-19 was utilizing existing building commissioning in that step 2 to bridge the gap between can I access it and can it do these things? So when we go through this technical version of agility, I think it's critically important that you stay abreast of what the local, not only what the local regulatory needs may be, whether that's weather or otherwise, including the EUI reduction that we just discussed, but also special instances. And when these come up, looking to the regulatory bodies or the bodies that provide us engineering guidance, like ASHRAE and others, to understand what current facility requirements they may have relative to these special events. Because as we know, there were so many things that happened in these facilities, right? The drastic occupancy changes, impacted revenue streams, let alone new liability exposure. So there were a lot of things that these folks were, sucked into really quickly without a lot of concrete answers. And ultimately, what we needed to do was understand, does it work and can it do what we need it to do now? So I'd encourage you, as you look through being agile with your customers, there are a lot of different ways in which we can approach or help them in this space. So as we talked about, financial and technical means of being agile, those are the 6 main ones that we see out in the field. I would encourage you, not only as a facility owner, but as a provider, keep these in mind when you have these discussions, because existing building commissioning doesn't have to be a whole facility solution that is expensive and disruptive. You can, through either digital or financial or technical means, produce projects that meet the requirements as soon as possible, are less invasive, less expensive, and meet those requirements oftentimes much sooner than would be expected in a traditional orientation. Lastly, I wanted to walk you through a few examples. What we've talked about here has been how we might orient ourselves to these sites and why existing building commissioning is important. But what we find is that we see performance at any size. It doesn't matter if we're doing an office campus overseas, where that has several buildings and complex systems and labs and data space. The same type of performance is seen in much, much smaller orientations as well, where either the size is physically smaller or the budget's smaller, or whatever challenge that they may have. So to start, I'm going to give you that big example, and this is our large case study. This was an office campus in the US. This is a global client. Their focus was on reducing their enterprise carbon footprint. So that was goal number 1. This campus included 6 facilities, all in operation, right? So none of these were brought down during this time. All of these were, workers day in and day out, still in the facility. What we did and where we were agile in this was kind of that digital forward existing building commissioning orientation, where we could identify what was going to be high impact for that carbon footprint goal, but also cost effective, right? Because these are several buildings all in operation. We need to be non-invasive, we need to be cost effective, and we need to hit that goal. So the digital orientation, so not just the tools and administration, not only helped keep our engineering costs lower through productivity, but helped with that big concern that they had about invasiveness, right? We still need to produce what we produce. Ultimately, this project was about $500,000, right? $530,000. The utility incentive kicked in about $250,000. And the annual energy savings was about $219,000. And for this one, we didn't include operational savings as well. But the simple payback falls right in what we were talking about earlier, where it can be anywhere from 1 to 5 per BCXA. But typically, for a lot of the things that you see in existing building commissioning, they're typically 3 years and under. And this one performed right in there at 1.3 years. So at any scale, especially on the large side, you can find a lot of productivity that you can pick up to meet goals specifically at that large size. And there are many that we hit here. But I want to give you the exact opposite view of this as well. This is a very small rural hospital. They were undergoing a controls migration in a patient wing, and they hadn't spent much time in this patient wing in years because they were typically at capacity. There wasn't a whole lot of space or schedule for them to work with in this area. So they wanted to kind of coordinate some commissioning to make sure that everything in that control loop worked per how they needed to operate that patient wing today, right? Those CFRs. By doing this, they were already going to have a migration in which they had to schedule some downtime in those areas. We were able to maximize that time by commissioning it at the same time, right? So thereby eliminating extra downtime for that commissioning effort. What's interesting about this, which is a rarity, is that the utility was not able to incentivize this due to size. They have Bryan criteria, all utilities do for the types of incentivization that they'll do. And this one fell way below their target. Regardless, even at this size, with a project of only $8,000, no utility incentive, and the annual energy savings was still $6,000 in a small patient wing. It still performed very similarly to the large scale example that I just gave. All that to say is when I show you these two, I know a lot of examples in our industry is people showing you the biggest and baddest jobs out there. We find that it fits somewhere in between overwhelmingly. You're going to have some of those large scale projects that companies have the budget for, they have the need, and they have the priorities for. But in reality, most of these projects fall somewhere in between this very small project and between that very large one that we talked about before. So when we're approaching existing building commissioning, having that agile approach allows you not only as a provider to meet that need across the bell curve of what you're going to see, but as a facility owner, keep in mind that these are the levers you have to push, have available to you to see the results that you need, and to develop not only short-term savings through the simple things that we talked about, which are typically controls measures, but also bolster your budget to understand down the line, what do I need to have in place, not only to fix the things that I have out there, but improve them as well, and potentially reduce my energy costs, reduce my operational costs as well. With that, I want to say thank you to everyone, first of all, but I believe now it's time for questions and answers. So I guess I will turn over to Sam, I believe, to field that.
Great. Thank you so much, Dewayne, for all that information.
Mhm.
Let's hop into it. If anyone has any questions, feel free to submit with that Q&A button that you see at the bottom of your screen. The first question is, often I face issues with the service or operation guys at the site not acknowledging the same. How do I face that? I think that is missing some context, or does that make sense to you?
A little bit. There's always going to be some spectrum of that, I think, at every site, regardless of what vendor or who that might be. I think when you're formally going through the existing building process, it's good to pull back the people that are typically on site and to level set through this process. And I think that's one of the main things that this can help provide is kind of a refresh on your site, to kind of level set everybody that's involved regularly. I think that's answering that question, but a lot of it is, time on site fatigue. Things are overlooked over time. By formally doing this, you can certainly reset that, though.
Next question is, how do you reconcile antiquated distribution systems, and they put as an example Fumatic zone controllers with agile data acquisition for the initial EBCx phases?
In short, that's the point. There's all kinds of systems out there, from dual ducts and all kinds of things. If you don't have a level set on what's there and how it's operating now, the gap is going to be, what is your current facility requirement, right? And I think that's the basis for not only assessment, but investigation, because you're trying to bridge that gap. So it's very important to understand what equipment you have and where you want to get to. But the assessment investigation, and particularly a lot of the data that you're going to pull, and quite frankly, some of the data that you can't pull will be very telling as well. We do these projects on pneumatic systems, and I can tell you there's not a whole lot of digital information that comes out of a pneumatic system. Ideally, there's digital information, and that makes the world a lot easier when we have that, obviously, from things like productivity to understanding what's going on. But that's not always the case, and that point is well taken. But you have to have a good understanding of what's there and where you need to be. And those are the initial phases of existing building commissioning that help fret that out.
Thank you. This next question is wondering, would as-built drawings be a tool to begin the investigation process?
Absolutely. Any information that you can get your hand on, the data that we might pull for an air handler will tell us when it needs to come on, what temperatures it's operating at, but it doesn't tell us capacity, right? So as-built drawings or our schedule of equipment are critical. You have to marry those with the data to understand what the impact will be. It can also help you understand what interdependent systems that you may be affecting. So having that information up front is always welcome, as much as you can get in the beginning, without question.
Great. Someone's asking about if the slides will be available. Yes, in about a week or so, everyone registered will see an email with the slides and then also access to this recording. Next question is your annual savings calculated or measured?
It depends. There's such a term in performance contracting, I think, that you're referring to, that's stipulated savings, right? Where it is assumed upfront that these calculations equal the savings that you will see. And there's a space for that. That engineering effort costs money, and some clients would rather take that in kind. I would say overwhelmingly, as utility providers are including more existing building style commissioning programs, it comes down to their requirements in a lot of cases for utility funding. So yeah, it might be a pre and post measurement. I think what I wasn't probably clear on is when you do that data assessment up front and assessment, that's often your pre-measurement. We have, in most cases, the utility informs us of what that post measurement might be, so they hit their criteria as well. So there's a spectrum. It's either calculated or people do require pre and post measurement. We see all kinds.
Perfect. And thank you everyone for the questions coming in. We have about 6 that just popped in, so I think we can have time for all of them. What type of opportunities do you find in buildings with smaller RTUs and split systems that are tied to independent T-stats?
Good question. It kind of varies on size. I find when I look for solutions for these, there's a number of solutions out there, a lot of which kind of bring them together in more of a web-based building automation system. So that is to say, they may have a series of new sensors that are applied, possibly a VFD, again, dependent on size, and some sequences that are canned that operate these. And then they go via Wi-Fi up to the cloud, and you're able to see all of your equipment. They may add another thermostat so you can see what your temps are per RTUs. That's pretty typical for RTUs. They're not a highly engineered piece of equipment. Usually you're looking for some vendor solution out there that can improve those as a bolt-on.
Thank you. Next question. Would this approach be different based on whether the building has been commissioned in the past? And if so, in what ways?
Not really. So you'll have, in a lot of cases, you'll have that initial construction commissioning, right, for the handover to the new owner. We find, and there's some industry information out there as well, that you can typically find significant savings if you're completing an existing building commissioning as soon as every 3 years. That's going to vary from site to site. How well are they funded? How well are they manned? How does their maintenance programs look? That varies, but in general, you'll find, I believe it's EBCx has some information out there that it could be Lawrence Berkeley National Labs as well. But typically every 3 years or so, you can find stuff pretty easily.
And another follow-up on the measurements. For the case studies, were the energy savings estimated or actual measurements over a period of post-implementation of the EBCx, FIMS, and ECMs? And if measured, does the savings analysis involve, I'm assuming they're saying some type of software like Copper Tree, or purely utility analysis?
So on the large example, that there was no cloud solution to take a look at those. We do or have done, I'm not sure where we're at in the process of that one right now, but we're doing regular physical checks, quick one-time data analysis to ensure that those are going on as part of the project, especially the large one. As you go through the utilities and they're spending large amount of monies to meet their reduction goals, they do require some kind of assurance that you're saving what you're saying that you're saving. So in particular of that instance, we were hand in hand with the utility to provide proof of saving. So for that one, it was pretty extensive post measurement to make sure that we were meeting that per their requirements, right? On the smaller example, once we found out the dollar amount threshold for that utility, the customer wasn't willing to pursue it any further. He had worked with us for quite a bit of time. He saw how we were saving it and where. We showed him the truth through analysis, but no physical post measurement for that one, which ultimately improved the cost of that project as well, especially at such a small scale.
Thank you. As for VAPs and VAVs and fan-powered boxes, I have seen issues with the initial setup for the coefficients from the balancer. So screenshot will not show this issue.
Agreed. 100% agree. Part of our testing, and I had to cut off some of the stuff that you saw for our terminal box analysis stuff. It is interesting how many of them are set up throughout their life as a the initial max flow. They're not set to an engineering flow, and various other things. I mean, there's so many of these boxes put out there that they're almost inherently going to have problems from day one, whether they were commissioned right for the new construction commissioning or not. Data analysis is not going to be a silver bullet every time. There are some things that you have to do physical root cause analysis on, and that's a perfect example. Those are out there. There are sites where we've seen, the initial startup on the fan and the air handler has been backwards for years, and you're not going to typically pick that up unless you're, real savvy with how the static pressure was working down that duct. But ultimately, you have to do a physical check on that stuff, and that's really the difference for me between the assessment and the investigation phase. Data is going to tell you a list of problems, but you may not have your root cause analysis. And that's a perfect example of one, too, where you need to physically touch the equipment. So don't feel that data analysis is the silver bullet. It can get you a lot of the way, but don't depend on it to be 100% of the way, because you're never going to get past needing to physically root cause analysis some of those things.
Say for 100 VAV terminal units, how much time would you expect to spend identifying the problem units that require commissioning?
With the tools that we use, we're talking a couple hours, and that's anywhere from 100 to 500. The only thing that would hold that back would be network speed or network traffic, but it's relatively quick.
Okay, thank you. I think we have time for about 2 more questions. How do you accomplish using technology to avoid using statistical analysis on VAVs if the existing BAs does not have automated VAV commissioning feature?
I see. There's a few ways to look at this. So the orientation that I'm looking at in this is the analysis that I showed is meant for assessment, right? It's meant to be directional. That doesn't mean that you may not find some value in doing additional engineering work to uncover some of those things. So statistical modeling is absolutely valid. But I think it behooves us to take a first pass and see directionally where do we need to be spending our time. And then if that initial check says that these 5 pieces of equipment or these 4 boxes are really where we need to spend our time, that may include that statistical analysis. But I think it's important to directionally understand where you're going to go first before you spend that time.
Has a pre-balance been used to verify the existing performance of the air and water systems?
It varies. Quite frankly, it varies for what we do on site. I would prefer, and this is just my former engineering brain, saying I wish everything was tabbed, and that would be a perfect world. We don't live in a perfect world. That would be the ideal, that everything is tabbed. But in some cases, we have to go off of tab documents that may be 2 or 3 years old, and that's our starting point, and then adjust from there. Not every client that has 200 boxes has the ability to carry a $50,000 tab budget, and so we have to be flexible with that constraint.
Okay. And one last follow-up. what if those 100 VABs use Funata controls and do not provide digital feedback? How much time do you think then?
I think we talked about this in an earlier question. Pneumatics provides generally zero digital information. So in a lot of those cases, you have no choice but to take that statistical approach. That may involve outside data gathering. So you still can get data from them. It's just much more costly to apply, say, a data logger to those to understand what's going on. And there's a lot more physical time spent with them. There's no way around that. If it doesn't produce data in which you can analyze it, that's not the path you take, is the short answer of it. Not everything produces the data that you're looking for, unfortunately.
Perfect. Thank you so much, Dewayne. I think you answered around 15 questions, so I really appreciate your time and coming on and expanding on this new approach to EBCx.
Thank you much.
Right. So I am going to just inform everyone of what's coming up with EMA. Dewayne, if you mind advancing your slide. We have a new opportunity to take the Energy Management Professional Seminar. It is a virtual opportunity, end of July, July 26. It's from 2 to 5 p.m. over a course of 2 days. And we have 2 all-star instructors, Al LaPera and Bob Knabler. We really look forward to having you attend. And if you want, you can just attend it and gain all this knowledge for energy management, or you can come on and bundle your pricing to work towards the Energy Management Professional certification. So if you need to learn any more about that, feel free to connect with me or just email info@energymgmt.org. Thank you so much. A last thank you to Siemens, and have a wonderful day, everyone. Bye now.